There I was, sitting in a room full of other statistics instructors, proposing my idea for how to revamp the stats curriculum. And I proposed 3 major changes. One is that we teach visually. So we focus on histograms and bar charts and scatter plots and that sort of thing. Second, we de-emphasize p-values, and instead we emphasize effect sizes and estimates. And third, instead of using a decision tree format that might look like this, we teach from a modeling perspective. So the basic idea is, instead of doing all these like decision trees to figure out what kind of analysis they do, everything is just run as regression. You want to do a t-test, run it as a regression. You want to do an ANOVA, run it as a regression. That way, there's only one model you have to remember, instead of a bajillion. Now, as I proposed these changes, I expected resistance to p-values, didn't expect much resistance to the plotting, but what I did not expect was such an emphatic rejection of a modeling perspective. It blew my mind. It did not make sense to me. Certainly, memorizing one procedure, the linear model, is way easier than memorizing 10 different procedures, like a one-sample t-test, a related t-test, a regular t-test, ANOVA, factorial ANOVA, chi-square, all these different things. Isn't it better just to remember one? That was almost 10 years ago now that that meeting happened. And there was something that I didn't understand then, and I just understood it very recently. And it came about because I was creating curriculum for another one of my courses, and I learned some things about how memory works. And I learned about stories. So even before like the internet, we live in a super information-rich world. Just like the amount of stuff that we're visually processing and auditorially processing and tactilely processing, etc. There's just a lot of information coming at us. And it's natural to think that we just record that information and store it in our memories. But we actually don't. Our memories are actually constructions. Because in order to ingest all that information, it would just overwhelm our brains. And so what we do is we create schemas. So a schema is a mental framework or a blueprint that we use to organize information. And these schemas help us to filter all the information that we see. And it helps us understand what is meaningful and what is not meaningful, what you can ignore, and what constitutes evidence. Or simply put, a schema is just a template. So let's just think about some examples. So a schema could be something like restaurant visit. I arrive, I get seated, I order my food, I eat my food, I pay, and then I leave. That's the template. And when you have that template in your mind, there's less cognitive load required to do that activity. I don't know if you remember the first time you flew in an airport. I think I was like 14 years old. I hadn't developed the schema, so everything was so overwhelming. I didn't know the proper sequence of events to do this and that, and it took me like 4 or 5 times before I finally understood, okay, this is the schema for going to an airport. And then when you have that template, then you can start to create stories. So a story is just an instantiation of a schema. So going back to the restaurant example, your story might be, I booked a reservation. I arrived 20 minutes in advance. And yet, I had to wait for 60 minutes. And when my food finally arrived, it was cold. And it was disgusting. And there was a bug in it. And then when I tried to pay, I found out they don't take a credit card. So that was a story, which follows the schema or the template. And just the details differ. But here's the thing. For a schema to be effective, it has to be meaningful. And it has to have a purpose. Because these schemas, they inform our lives. They tell us what to do. And it tells you the relevance of all the information you get. It tells you what questions to answer and how to find solutions. And if the schemas we develop don't have meaning and they don't have purpose, then they're essentially useless. And that's how the current curriculum operates. It doesn't really offer a schema. It doesn't give you a mental framework. Or if it does so without meaning. So the current curriculum might tell you what numbers to look for, but it doesn't tell you why. And if a schema doesn't have purpose, then the best a student can do is just memorize the information. But they're not really going to understand it. And I have been teaching statistics for 15 years now. And about half that time, I was teaching the old curriculum with the t-tests and the ANOVAs and the decision trees and whatnot. And in all my experience teaching that, I never once had a student actually understand it. The best and brightest students I ever met were just really good at memorizing, but they didn't get why. And as I was thinking about this, I realized that that was my big problem as an undergrad. And I didn't even know what the problem was. See, I was a psych major, and I took statistics within my psychology department. And I got an A in the class, but I didn't get it. I was like, what am I missing here? I don't get it. And I didn't even know what I didn't get. And so I remember I went to the bookstore and I said, there's got to be something that I could find. And I found this like little statistics primer book, and I bought that because I just wanted to know what was going on. And I think the reason why I wanted to buy it was because I had decided to minor in stats at that point. And I thought, well, I better understand stats if I'm going to minor in it. And I read through that primer and I just still didn't get it. Okay, we got this t-test, we've got distributions, we've got means, we got medians, we got modes, but what does it mean? And it was only once I moved out of the psychology department and started taking stats from the stats department that I finally got it. Because I finally had the scaffolding or the schema or the template or the blueprint that I could use to interpret information. In preparation for this other class that I'm teaching, as I've been thinking about schemas and stories, I realized something. I failed to convince those other teachers to change the curriculum for the same reason our students are failing to understand statistics. And the reason is that we don't appreciate the value of stories. And I'm going to talk about both parts. I'll first talk about the student stuff, and then I'll talk about how that relates to other instructors. So the current way that we teach statistics, it fails because it doesn't teach students a schema. And this hit me really hard, so much so that I nearly passed out from trauma to the frontal lobe when this clicked for me. A couple weeks ago, I was doing a peer observation of a fellow teacher who was teaching statistics. And it was the first time I'd observed a statistics class taught in several years. And so it was interesting to contrast the traditional approach to teaching statistics with what I did. And honestly, she was doing a great job teaching the existing curriculum. And what she did was she showed output from SPSS that looked something like this. And so she said stuff like, all right, ignore all this output. First, you're going to look at Levine's test, which is right here. And if this p-value under significance is greater than 0.05, then we look at this p-value in that row. Otherwise, we need to look at this p-value in that row. And remember, she said, we do not want statistical significance when we do Levine's test, but we do want it for the other test. Now, if you have quite a bit of background, you understand exactly what I just said. But do you notice what's missing? The why. Like, why did we ignore this part? Why are we looking at Levine's test? Why is one p-value supposed to be greater than 0.05 and the other one is supposed to be less than 0.05? Now, of course, we could answer these questions, and that'll get technical. And answering those questions does not a schema make. But the most important omission that is consistent across every teacher who uses the standard curriculum. The biggest omission is none of this tells us anything about our data. They kind of sort of tell us something about the hypothesis, but they don't tell us about our data. And as I was watching this, the only indication of why this was important was she would say, now you got to remember this because on the exam, you're going to have an output like this. You're going to have to find the right p-value. And that seems problematic to me. Again, it's not a fault of the teacher. It's the fault of the curriculum because it is entirely missing the schema. Instead, students are asked to memorize a sequence of steps without any meaning, without any rationale, or if they are given a rationale, it's not organized in a coherent framework that they understand why that rationale is important. And it's all done in the name of doing it right because someone told you this is the right way. And that someone knows more than I do, so I'm just going to follow the right steps. So it's very rich in ritual, but it's very weak in purpose. So why do I compute a p-value? Why am I going to compute a confidence interval? Why am I testing whether normality exists? What do these results tell me about my data? What do they tell me about my research question? What do they tell me about my hypothesis? So let me put this very succinctly. All students fail to understand statistics, as traditionally taught. And the reason they fail is because the curriculum lacks meaning. Or another way to put it, it fails because there is no story. There is no schema. There's no way to organize the information in a meaningful and purposeful way. Now let's try a similar analysis, a t-test, but this time we're going to embed it within a story. So let's come up with a good example. Let's say there's a new medication out that we're thinking about trying that may or may not be revolutionary in the treatment of cancer. And let's say that I just got cancer. To me, it is very, very important to find an answer about whether this medication is going to work for me. And so I gather these data, and the first thing that I want to do is I want to plot the data. And so maybe I find numbers about a treatment group and a control group, and I plot something like this. When I look at this plot, the first thing I ask myself is, what does this mean about my data? And so I see that there's a separation between these two. That it does seem to be that those who take the medication have lower values of biomarkers of cancer. By the way, I make no claims about the biological correctness of the data that I'm presenting. And so you might look at that and you say, yeah, I think the group that is taking medication has better outcomes. But how big of a difference is that? Well, let's find out. So maybe we decide we're going to compute the mean of one group and then the mean of the other group. And we find a mean difference that looks like this. And we might say, okay, cool. A mean difference of 4.34. Awesome. What does that mean? And the problem is, like, a 4.3 or whatever I said, like, is that a big difference? I don't know. Because this biomarker outcome, I know nothing about it. I'm not a medical doctor. I'm not a cancer researcher. I'm not an oncologist. So maybe I'm going to translate that into a metric that is more familiar to me. So I might choose to do standard deviation units. And of course, if you don't know what standard deviations are, and if you don't know what a Cohen's d is, a standardized mean difference, that might take some training, but that's okay. That's not hard. Because now we know why. We want to know, how big is this difference? And we see, oh, that's actually a respectable difference. But now your question might be, yeah, but maybe this happened by chance. Maybe it's just a fluke of the data that we collected. I mean, the sample size looks like it may be respectable, but maybe it's too small. I don't know. If we allow probability into the mix, is that like a meaningful difference? I don't know. Let's find out. So we might calculate a p-value, or a Bayes factor, or an AIC, or a BIC, and you might get results that look like this. And sure enough, wow, look at that. All the numbers are basically telling me that, yeah, if you take this medication, your biomarkers look a lot better. And at this point, you might be good. Say, all right, I'm going to take the medication. But maybe you might say, hey, you know what? I'm different, though, because I'm like super fit and I eat right and I exercise. So does that apply the same for those who exercise versus those who don't? And so maybe you decide to do another analysis with the same data, and you decide to control for how healthy they are or how much exercise they get. And you might show another plot that looks like this. And then you might notice, oh no, those slopes, they're not parallel. It seems that people who are healthy respond better to medication than those who are not healthy. But is that just a fluke? Maybe we should do another model comparison. So hopefully you get an idea of how this works. So when we teach statistics from a modeling perspective, there's story built into it. Not only is there a story built into it, but there's story within story. Because we've got, one, the story of why my analysis matters. Because I'm about to die. That's kind of important. That's kind of meaningful. That's a research question I can get behind. But also, we have the story of the actual analysis. What are my data trying to tell me? And you do not get that with the standard curriculum. But with this approach, you are giving the students a framework, a blueprint, a schema that they can use to tell their own stories about their own data. That's powerful stuff. Now, as I was reviewing this, actually, as I was doing this peer observation, I started to ask myself, okay, I get it. Like, the standard curriculum It is schema-less, blueprint-less, template-less. But is it possible to try to embed a schema within the existing curriculum? And I thought, well, maybe, but it's still going to be super awkward. Now, don't get me wrong. You can still tell the story of why your data analysis matters. And you could always be bringing that back to the original question, which is actually what I suggested to this instructor. But it's going to be super hard to have a meaningful story about a decision tree. Like, hey, how many predictors do you have? 2 or more. That's important because multiple comparisons, but I'm not going to tell you about that now. Are all the independent variables numeric? Yes. Why does that matter? Because you could do multiple regression. Oh, but by the way, you could do multiple regression on everything on this table. So yeah, it's going to be really, really hard to come up with an interesting and meaningful story for a decision tree. It's going to be lame. Now we get to how this relates to instructors. Here's the irony. So schemas are extremely effective and very resilient. And as you can imagine, it's really, really hard to build an effective schema using decision trees. And those who have successfully done so have worked their tails off for years to do it. That sort of schema only comes after you've been teaching stats for several years. But that's also the problem, because schemas are super resilient. So the problem that I was running into is that my fellow instructors had really deeply embedded schemas. And schemas have a way of entwining with our sense of identity. And that right there is why it has been so hard for me to convince other stats teachers to change their curriculum. Because to suggest that we change the way they teach becomes a threat to their identity. Because these teachers have internalized the idea that they teach stats effectively, and they do, given the curriculum. But the problem is that's not just a belief. It is deeply tied to their sense of competence and their sense of personal identity and professional identity, as well as department norms. And so when I suggested alternatives, they felt like attacks, which led to my ideas being nitpicked or dismissed, treated as a fad, or treated as if I was like overcomplicating things, when in reality I was simplifying things. And for these super seasoned, experienced teachers that are really good at teaching that curriculum, no amount of evidence is going to change their mind. Because again, what do we do with schemas? We use our schemas to filter information. So if information comes in that is perceived as a threat to the current schema, it gets filtered out. And just as an example, about a year after that original meeting, I decided that I was going to do an experiment. Quasi-experiment, technically, but what I did was I compared 2 classes. One taught the traditional way, one taught the modeling way. And then with both sets of students, I gave identical questions. There's like 20 questions or something shared between the 2 exams. And I compared their results. And the students who were taught from a modeling perspective did way better. And I asked them for their opinions on how they perceive the curriculum. And they were super enthusiastic. And a lot of these students had already taken stats before. And they said, wow, this was so much easier. Why doesn't everybody teach it this way? And so in preparation for this meeting, I told one of my fellow instructors, I have evidence that this is effective. And no lie, she looked straight at me and she said, no amount of evidence will change my mind. And I was shocked. It's like, aren't we scientists teaching students about gathering evidence and the importance of gathering evidence and that we don't trust our intuition, we trust evidence? And I was upset and thought it was dumb and stupid and lame and hypocritical. But now I'm like, well, she was right. Her schema was so deeply entrenched that all evidence that I presented would have been filtered through that schema, and nothing would have changed her mind. So it's a dilemma. And what do we do about it? Well, I actually made a video about it. Those videos I don't publish because they're not stats related, they're psychology related. If you want me to publish those videos, I can, but I can still leave a link in the description so you can watch this video about how to persuade people. So the first thing is what we can do for the students, and that is to build a better story for the students. Always link statistics back to the questions at hand. So we make the procedures serve the story, not replace it. It's not a sequence of steps that we're following, but we are encouraging students to be curious and giving them the tools they need to satisfy their curiosity. And what about with teachers? Well, I will tell you what doesn't work, and it's probably obvious, for these deeply entrenched schemas, evidence isn't going to help. Facts aren't going to help. Arguing isn't going to help, because they're just going to use their super powerful filtering mechanism from their existing schema to dismiss whatever you say, which is what we all do. And so the idea is that we don't persuade them from our lens, we persuade them from their lens. So I think the starting place is to understand what their values are and to understand why it is that they teach the way that they teach. Figure out what's important to them. Then once we understand those values, then we affirm those values. Because it would be very strange if they developed these schemas for nefarious purposes. That would just be weird. Usually they care about the students, and they think this is what's best for them. So we affirm those values. And then what we do is we reframe the proposed change to a model-based perspective in such a way that it is identity affirming. So like maybe, for example, you find out that for them it's very important to be student-centered and that the student comes first. Great value that a lot of teachers share. And once we understand that value, then we can start communicating about how a model-based perspective is very student-centered because it tells a story. And humans are story-greedy people. We love hearing stories. And so what can be more student-centered than teaching data analysis as a story? And I also think this has applications for us personally. I remember I was interviewing, like right after graduate school, I interviewed for a job, and it was actually a really cool interview. They gave us a data set and a research question and asked us to analyze the data. And being fresh out of, actually, I hadn't even finished graduate school yet. I was in my last year, and as I analyzed the data, I did all these like sophisticated analyses, and like I was very confident in my results. And I presented my results to them. And at the time, I was super focused on p-values, and I said, hey, this is statistically significant. I think it was like a teaching focus, something or other, like trying to identify if some teaching method worked. And I said, hey, this is an effective method. And they said, great. How large is the effect? And I was actually given a PowerPoint presentation. I was like, let me go check. And I went on my computer and I realized the effect size was super tiny. I was like, oops, I had missed the story because I was so focused on details. And I find myself still doing that to this day. In fact, if you've watched my last series of videos on my CRIM model, I got totally stuck in a loop of doing a bunch of procedures and chasing something that actually wasn't all that meaningful. So I think it's very important when we are doing data analysis to regularly have check-ins. It's kind of like on my Apple Watch, every hour it says, hey, you should stand up or you're going to die an early death because you sit down too much. It'd be nice if we had like an Apple Watch for data analysis that every hour or so a prompt comes up and says, hey, are you thinking about the big picture here? Like, what are you actually trying to do? I think if I did that more frequently, I would have done better data analyses in the past. And finally, I think the last suggestion I have is to take a stats class, baby, with simplistics.net. That's me, by the way, if you want to meet me live and in person, virtual, Zoomy, then yeah, please take a stats class. I have a mixed model class coming up in like 2 weeks-ish. And you know what? It's Christmas time, so I'm going to give you a discount. 20% off. See the link in the description, as well as a coupon code. So hope to see you in my mixed models class. And boy, it'd be more convenient if it were a intro to simplistic class. For those of you who are like, hey man, it'd be cool if I could figure out this like data as story approach. Tell you what, I'm going to do a class in February. There you go. Just for you, my lovely audience. Anyway, hope to see you there. Good chatting with you. Peace out. Well, it seems we are having a bit of technical difficulties. La da da Man, I tell you. No, because that's a stupid idea. And I don't think about stupid. You know what? Too many words, all right? You think this is a stats channel? How very rude of me to tell you how to be better. Jeez, I'm so mean. What is that, you ask? I don't know. I learned about it like a week ago. Jeez, give me a minute. You think that's a simple way? In a simple manner. Okay, let me let you in on a little secret, audience of mine. If you preface what you're saying by, it's simple, really, or this is easy to understand, that does not automatically make your next statement intelligible. Got it? Johnny Cochran reference. Man, that's you got class there, man. It's not every day that somebody can pull off a Johnny Cochran reference in a stats video. He said, if it don't fit, you must acquit, when he was talking about the glove. And I said, very fitting for a criminal model. With which to work to identify. If everything worked.